compound interest today. As I mentioned, this is our last topic, our last set of notes for Unit 8 before we test. I'll pull the calendar real quick before we start the notes. So today is the 4th. We're doing compound interest. We'll have some practice in Delta Math. Tomorrow is your review day. Remember, the review has been open and aware since last Thursday. I really hope you've gotten started on it. Speaking of reviews, when you go into Aware on tests available, if you still see a Unit 6 or Unit 7 review, you may still do those. I would not do them before the Unit 8 test. I would focus on the Unit 8 review. But after this Unit 8 test this week, you can see we have 4 days to finish up your topic goals for that SAT prep in ALEKS. Remember, the goal is 50 topics. Okay, some of you last Friday is the last time I checked the progress, but some of you last Friday were close. Like, you were maybe only 10 topics away. Some of y'all had 40 something topics completed. Okay, some of you were at 0 because you have not been doing anything those days. So you've got a long way to go. You may need all 4 of these days fully. But if you finish your 50 topic goals, okay, and we have some extra days here, I would go back and do any missing review that's still available in Aware, any test corrections that I have not done, and then any Delta Maths that I have not completed. Okay, we are going to do the Unit 8 test corrections, okay, for this upcoming test, okay, a week after. We're going to do them together as a class. So you won't be doing those individually any of those days, but you could go back and correct Unit 6 or Unit 7 if needed, or retake those if needed. But just so you know, that's the plan, okay? All right, so compound interest. Compound interest occurs when interest is calculated on both the principal amount and the accrued interest so far. Okay, so you may not be familiar with this, maybe because you don't have any accounts or maybe credit cards or anything that's earning or charging interest. But you might be familiar. I don't know. I'm not going to assume. But there is a formula for compound interest that we're going to write down, and then we're going to define all of the variables, all of the letters that are in it. So pen. There we go. I finally got, I know my pen wasn't working yesterday with y'all, but I finally got it working. All right, so A equals P, and now it does matter capital and lowercase, so that's a capital A and a capital P. And that's a lowercase r and n, and a lowercase n and t as the exponent. Okay, so this is our formula for compound interest. Okay, so the P is what we call the principal or initial. We talked a lot about that word initial, but when we're talking about the money that you start with in an account or an investment or something, that's called the principal. Okay, or the initial amount of a loan or something like that. That's your principal. Okay, R is going to be the rate. Okay, now in the equation, you need to make sure it's as a decimal. In your word problems, it's probably going to give it to you as a percent, and you've got to convert it to a decimal before you put it into the equation. Okay, so N is the number of times it's compounded, the interest is compounded per year. So there's going to be a lot of terms used that we need to be able to interpret. How many times a year is that? So if I say annually, how many times a year is that? That's once. If something happens annually, it's once a year. Okay. Something happens biannually, That's bi means two. It's twice a year. If it's monthly, how often is that? That's 12 times a year because there's 12 months in a year. If it's daily, how much is that? 365 because there's 365 days in a year. Okay, so that N is the number of times it's compounded per year. Okay, so we have to be able to interpret the terms like monthly, annually, daily, etc. And then T is our time. Okay, so let's take a look. I'm going to actually, I'll do some color coding here if it'll let me. So it's only, it doesn't let me highlight my own writing for some reason. I hate this. Well, I guess maybe I'll just go over it in a different color. Okay. Do principal in blue. Okay, the rate in red. Number of times compounded shows up twice in your compound interest equation. And time do in purple. And if you have a highlighter that'll work on your paper, I would probably prefer that. But all right. This first one says that Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay, so what is the initial amount she deposits? It goes faster when y'all participate. What's the initial amount she's depositing? 12,000. So that is my P. That is my principal. So 12,000 is going to be my P value. Okay, grab that sheet right there. All right. Yeah. And then let's see, it says 8% interest. That's my rate. But what do I write that as? I write it as a decimal. What is 8% as a decimal? 0.08. Move it 2 places or divide it by 100 if you want to think of it that way. This percent's always out of 100. Okay, how much money will she have in 5 years? What does 5 years represent? That's the time. Okay, oh, I did that in the wrong color. That's the time, which we're doing in purple. Okay, so 5. And if you want to add up here, your time is almost always going to be in years. All right, and then last but not least, how often is it compounded? Now, what does that mean? Quarterly. 4. 4 quarters and a dollar, right? 4 quarters and a whole. Quarter plus quarter plus quarter plus quarter equals 1. Okay, so quarterly means 4 times a year, and it's every 3 months. Okay, so that's going to be my N. I'm multiplying that N and T up there in the exponent. So 4 times 5. We didn't write this up here. There was not a space for it, but the A, the reason we used A, that is the annuitized amount, which is financial word for saying the amount calculated after the interest. Okay, so that's our ending amount. So the initial amount is the principal, the ending amount is the annuitized amount. Okay, so that's why I use A and P. All right, so now this is just a calculator question. So I'm going to type this in. Let me split screen here. Okay, so 12,000 times 1 plus, and it's 0.08 over 4. And this is to the power. Now you can type 4 times 5, or you can go ahead and multiply that and get 20 and type 20 as your exponent. That's up to you. Okay, so I've calculated this now, or I've had Desmos calculate it. Okay, and this is what it comes out to. Now we're talking about money, right? What place value should we round to when we're talking about money? Should I write all of these? No. What place value? Where should I stop? The hundredths. Money, like your cents is only going to go up to 99 cents, right? Because then when it's 100, it rounds up a dollar, goes up to the next dollar. Okay, so hundredths place for money. Okay, if you need to make note of that on your notes somewhere, hundredths place for money, make note of that. So we look here at the 6 is in the hundredths place, but you always look to the right one place to see if it rounds up or not. So that 8 is 5 or greater, so it's going to round this 6 up to a 7. So this is going to be 17,831 and 37 cents. So I'm going to put the money sign because that's my unit of measure. You'll feel okay about that? All right, so that's pretty straightforward. Let's look at the next one. Says Jack moved $25,000 of his savings to a new investment account that earns 4.5% interest compounded monthly. Find the total in the account after 6 years. Okay, so what is the principal? 25,000. That's what he's initially investing. All right, and then his, let's see, his rate is 4.5%. What's that going to be as a decimal? 0.045. You move the decimal 2 places. If you can't do that in your head or you forget, just divide by 100. Take your percent and divide by 100. It's going to give you the decimal. So 0.045. It says here it's compounded monthly. How many times a year is that? How many months in a year? 12. So my N is 12. Okay, and we're trying to calculate how much is left after 6 years. So my time is 6. Okay, so now it's calculator question. Now that I know where everything is supposed to be plugged in, I can type it in Desmos here. I'm just going to change this one I've already got written. So that's going to be 25,000. Going to be 12 times a year. And that's at 0.045. Okay, so for my exponent, it's 12 times 6. You can, if you know what that is, you can write it. If you don't, when you're up here, you can do 12. If you're going to do it, you have to use parentheses because you're putting more than one thing. So 12 times 6. Okay. Double check, 25,000, 4.5% compounded monthly after 6 years would come out to 32,000. $732 and how many cents? 58. Good. Pretty good return on investment there. All right, an investment account pays 3.5% interest compounded semi-annually. If 4,000 is invested into this account, what will be the balance after 12 years? Okay, so let's write it out. All right, so initial amount is 4,000 is invested. So that's my P, my principal. Okay, this one pays 3.9% interest. So my R is 0.039. And it says it is compounded semi-annually. What does semi mean? Twice. Think about a semicircle, okay? Is a half, it's every half a year. So that's 2 times a year, okay? A semi truck is a half-ton truck. Semi means half. So if it's every half year, that's twice a year, okay? Every 6 months. All right, and they want to know what's going to be in there after 12 years. So my T is 12. All right, now I'm ready to calculate. $4,000 at 3.9%. Oh, 12 years. We're keeping 12 years, right? Oh, that's not, sorry. Twice a year, that's my N. Changing the 6 to 12. Okay, so when I calculate this, he's going to end up, whoever this was, is going to have 6,358. How much change? 48. That one does not round up. You leave it as 48. All right, so we've got that total after the 12 years. Thank you. All right. Let's go ahead and flip over. Now, I'm just looking at these. These all are investments, but I want you to know I know some of y'all are old enough to start getting bank accounts and maybe credit cards and stuff. And when you go off to college, there are people like posted up all around trying to get you to sign up for their credit cards. Be smart, okay? Because yes, these are examples of compound interest with people making money because it's investments. Compound interest is also charged on like for if you borrow money. So like on a credit card. Okay, so if you spend this much money and then they start compounding your interest, okay, repeatedly, and you start owing so much interest that you get into a point where your monthly payment is just paying the interest and you're not paying down any of your principal, and it can spiral out of control. Okay, so be wise. Okay, do not spend what you don't have, because that's how people get into crippling debt. Just my little suggestion, life lesson there. All right, last backside here. It says a savings account. These numbers are off. That's another number 3. Savings account offers an 8% interest compounded bi-monthly. If Bob deposits 300 into this account, how much interest will he earn after 10 years? Okay, so let's identify all those important pieces. Okay, so this is going to be $300 is my initial investment or deposit. The rate. Now, don't get mixed up here. Some people see a percent, a decimal percent, and they think, oh, it's already a decimal. If you see that percent sign, you still need to move the decimal 2 places. So what is this going to be? 0.008. Whoa. I don't know why that's trying to happen. 0.008. All right. Compounded bi-monthly. Got to interpret that. Bi means twice, right? 2. So if it's 2 times a month, how many times a year is that? 24. And they want to know how much will be in here after 10 years. So 10 is my time. Okay, plug this one in. So 300 initial amount, 0.008 as my rate. 24 times a year is how often it's compounded. And so after 10 years, this will be up to $324.98. That's not a very, you made $24, almost $25 in 10 years. That's not a very good interest rate, 0.8%. Okay, I would look for something with a better rate. Now, if you're only being charged 0.8% interest, that's a great deal. Okay. All right, last one. We invest $750 into an account that pays 3% interest compounded weekly. How much interest will you have earned after 20 years? Now, we didn't talk about this, but I just want to discuss this one that's always here. Remember when we were doing exponential growth and decay, we're always comparing our base value to 1, right? Because 1 is 100%. Okay, and so you're starting with 100% of the principal plus the interest rate. Okay, so that's why this 1 is always here. Okay, just in case anybody was questioning that. All right, so we've got $750 invested at a 3% interest. So my R is 0.03. And this is compounded weekly. How many weeks in a year? Anybody know? 52 weeks in a year. So my N is 52. How much have you earned after 20 years? So my time is 20. $750 initial or principal. Okay, 3% for my rate. 52 times it's compounded every year. How much after 20 years? So this one comes out to $1,366.35. Pretty good. Now, you'll notice the larger the initial investment, obviously the bigger the return. Okay, if you're only depositing hundreds of dollars, okay, you're not going to see like a huge amount at the end. Okay, but if you're investing obviously thousands, you're going to get a bigger return. Okay, because it's a percentage based on your initial investment. So that's it for the examples. Now, what I would suggest, okay, some of you, when I was asking what does this mean for how often it's compounded, okay, I don't know if y'all just weren't responding because it's too early and you're not all the way awake, or if because you didn't know what those terms meant. Okay, so somewhere on your paper, okay, maybe down here at the bottom or something, you might want to make a list of those words just to refer back to, okay, for your in value. So things like annually, semi or biannually, is twice a year. Let's see, quarterly, 4 times a year. And maybe you'll see monthly or semi or bi-monthly. Weekly, and then daily. Those are probably the terms that you will see most often for these. So annually would be 1, semi or biannually would be 2, quarterly is 4, monthly is 12. That would be 24 if it's twice a month. Weekly is 52 and daily is 365. So if you want to have just a list of those values as a reference, I don't think that's a bad idea at all. Okay, because the actual work on these problems, the Desmos is doing the work. You just have to make sure you're identifying the correct values for the correct variable, plugging them in the right spot. Make sure you changed your rate to a decimal. Okay, divide that percent by 100. Okay, and make sure that you chose the right in value based on how they described how often it was compounded. Y'all feel okay about those? Awesome. Okay, I'm going to activate the practice in Delta Math for you here then. And y'all are going to have some time to try these on your own.